Here in this video, we'll see a problem on projection of lines inclined to both the planes. For that, here is a question. The front view of 85 mm long straight line AB measures 60 mm while its top view measures 70 mm. Draw the projections of AB if its end A is 10 mm above HP and 20 mm behind VP while its end B is in the first quadrant. So this is the question in front of us. Whatever is given, I'll write that in the form of data so that we can understand how many parameters are there. There should at least be 5 parameters to solve this problem. The front view of 85 mm long straight line. So this 85 mm long straight line is the true length of the line. Then the front view is 60 mm, so that will be called as elevation length. Top view measures 70 mm, so that will be called as plan length. Draw the projections of AB if its end A is, that is point A is 10 mm above HP and 20 mm behind VP, while end B is in the first quadrant. So point B is in first quadrant, and here when it is given that the end A is 10 mm above HP, 20 mm behind VP, it means it is in the second quadrant. So I'll say that point A is in second quadrant. So here this problem involves 2 points which are there in 2 different quadrants and we have to join them. So let us get started with the solution to this problem. First, I'll explain about the second quadrant here. VP and this is HP. So point A is 10 mm above HP and 20 mm behind VP. So 10 mm above HP will be seen in VP, that is somewhere here. I'll say this is point A. Then 20 mm behind VP will be along this line at this location. So this will be A dash, this is point A. So point A dash, it is 10 mm above HP and 20 mm behind VP. So this point A will indicate the top view, whereas A dash will indicate the front view of the point A. Next, when I am going to tilt this HP and make it parallel with VP in the clock direction, then both the planes are going to overlap. So when they will overlap, in that case, here we have VP HP, then point A will be 20 mm above and point A dash will be 10 above. So here are the locations at 10 height. In VP, I'm going to get point A dash, which is the front view of the point A, and the top view is at 20 distance, that will be at point A. So A dash indicates front view, A indicates top view, and since it is in the second quadrant, the points are overlapping, that is front view and top view are overlapping here. So now I would be starting with this location of point A in the solution to this problem so that we can understand that how it should be done. Now first I am taking a light horizontal line which is XY line. Here there is VPHP. So first I am going to locate point A in a similar manner. We have understood that HP VP are overlapping here. So for point A, I am drawing a light horizontal line here, light vertical line. Then I locate point A 20 at 20 distance, point A dash at 10 distance. They are overlapping because for point A, this will be the second quadrant. So here I'll say this is point A dash and here is point A. Now after locating point A, here A dash is at 10 distance and this is point A, not A dash. So this 20 location of point A, which is behind VP, that distance is visible from the top. So I'm going to draw the top view from A and front view from A dash. EL and PL are given. So EL will be for the front view, that is drawing a light horizontal line from point A dash and marking EL, that is 60 over that. Similarly for PL, I'll draw light horizontal line through point A and I'll mark 70 over that. I'll give this point notation as B2 and here this will be A dash B2 dash. Then after this I'll project B2 dash upwards. So here I'll give this point B2, I'll replace it with B1 because that is the standard notation. Next, when I've projected B1 over this from A dash, I will draw a line which will give me the point B dash here, and for that I'll require the true length, which is 85 So measuring 85 true length here. After measuring 85, keeping it on A dash and cutting this line which is passing through B1. Now that will give me the true length of the line, which will be called as B1 dash. So I'll draw this line, and now there will be intersection of front view and top view because one point A is there in the second quadrant, B is there in the first quadrant, so there will definitely be intersection of the line. So for that Similarly, I'll project B2 dash downwards, keeping the same true length because true length will remain same both in the front view and top view. Keeping it on point A, I am going to cut this line to get this point, which I'll say it is point B2. Joining A with B2 will give me the intersection. Now if we see here, A dash B1 dash is the true length, and that is the true length in the front view. A and B2, that is the true length, but it is there in the top view. And as we see here, there are intersection of these two lengths because one point is there in second quadrant, another point B is there in the first quadrant. So there has to be intersection between the planes when we draw a line. Next, after reaching here, these are the true lengths, so I'll make them medium dark. True length should be kept medium dark. And then through B1 dash, I am drawing a light line. That will be called as locus of point B dash. And then I'll simply measure the elevation length here, which is from A dash to B2 dash, which is 60 mm. I'm measuring this elevation length and cutting this locus to get the point B dash, joining it with the help of light line. That will be from A dash to B dash with the help of light line. Then I'll make it dark. Then this is the actual length of the line, which is called as the elevation length. It is equal to 60 mm. Now projecting a light line from B dash downwards, like I have drawn it from A dash. Similarly from B dash. Within these end projectors, the top view should also end like the front view is ending between these two end projectors. So again, in a similar manner, now I'll measure the distance from A to B1 because that is the PL, and drawing a locus through point B2, locus of point B, measuring the distance A to B1. I'll transfer this distance onto the locus. I'm getting this point. So joining it with point A, light. This gives me the point B, and here I'm getting the intersection, which is from A to B. This is giving me the PL, which is 70 mm. The TL is 85. Here there is A dash B1 dash, that is the inclination of the true length in the front view. So then I'll call it as theta, and this is the inclination of the true length in the top view, so that will be called as phi. So therefore inclination of A dash B1 dash, that is theta, is equal to 34 degree, and inclination of AB2, that is phi, is equal to 45 degree.